So we're still in chapter 5. There's a lot of information in chapter 5 about electrical components. We talk about some of these. We talk about motors, solenoids, switches, open circuit, short circuit, circuit protection. Where are we protecting the circuit from? Overload. What are the 3 protections we have? Fuses. What else? Breakers. What else?
Magnetic overload.
Magnetic overload. What are relays? It's called switching relays. So from the name you can think that they switch one circuit on and off based on an input. We have 3 types of relays on the market, in the field, and they are rated based on what? Amperage. So what are the 3 we have? Relay, contactors, and the third one, gas? Magnetic relay, magnetic contactor. So anything above 20 amps is a contactor. If the contactor has circuit protection, it is a magnetic relay. What else did we talk about? Lights for indications. Electric heaters, solenoids. We covered a lot. Regular switches, toggle switches. So please try to skip through the chapter. We'll go through the questions once we are done. We'll move from here to schematics. Schematics are very important. They're like the map that will lead you to understand where everything is located. So if you want to go somewhere, probably get into GPS. The map here is schematics, because if you think of current as a person moving, electron moving, you want to see what street they're going through and what are the intersections. There's going to be a lot of intersections. There's relays or connections. You're going to make all these. So you're going to need a map to know how are things connected. Are they parallel? Are they series? How does the current divide? What does it go through and what is it doing? So schematics, they can be very complex or very simple. Example, you look at a map. I can give you the name of the roads, that's it, and distances, right? Or I can put more details, give you all the stores in the way, all the intersections, correct? Or it can be more details. If you go, for example, and put on Google Earth, you'll see everything. Do you need to see everything? Not always, but sometimes you do. So more details. If you look at regular GPS, it only shows you the road and the intersection to make things a little bit less overwhelming. If you put more details, it will be too much to see and a lot of information you don't need. So we have 3 types of schematics. They will tell you how, when, why the system works, once it's energized, and what is its situation when it's de-energized. It also includes the symbols, line, representation. What do you mean by lines? When we see a line in the schematic, what does it mean? Wire, thank you. It's wiring. Some schematics are colored, some of them are not colored. So you have to rely on what it says on the beginning of the line. Is it line voltage or is it neutral? Some schematics are colored, which is easy. Some of them, they will even say the color on the wire, even though it's printed in black, it will say purple, blue, or green. Pictorial diagrams. They're also known as label or line diagrams. They show the internal wiring of a component. And I give an example of the primary control here. I think it's in the back. But it shows you what's the internal component, what's in there. Probably there's a relay, there's a switch to show you what's inside the equipment. Components are not shown in the control panel, are shown outside the panel on label. So you'll see, I'll show you next schematic, what are the components inside this diagram. Factual diagram consists of pictorial diagram along with schematic diagram. So it has all the components and all their internal wiring. So probably you see a motor, not only the circuit, not only a circle, but you see the wiring of the winding inside. So it has more details. An installation diagram. So we have pictorial, we have factual, and we have an installation. An installation is the simplest one. It gives specific information about the terminals, wire size, color coding, breaker fuse size. They do not give you details about the information. They show you little internal wiring because it's less overwhelming. So basically it tells you connect line voltage to, for example, contactor. Contactor wire comes up and goes to a compressor. Compressor line coming out, the line coming down, the compressor will go all the way to neutral. So these are the installation diagram. They're simpler and they're color coded, and they tell you which wire goes where. And I'll show you here.
Is this something that you want to write down?
Huh?
Is this something that you want to write down?
You could,
Write down?
but it is on blackboard, as long as you have differences. So if we look at this board, it's not a wiring diagram. So this is an aquastat, and this is the actual board that you will install. If you notice here, most of the terminals are labeled. So probably at some point we will know what these terminals mean, what those symbols are. So if you look here, it says B2 and B1, and they put the effort in putting burner, which is the burner motor.
What's that called again?
Aquastat. Aquastat.
Aquastat?
Yeah. You'll know it by heart in a while, don't worry. But it's an aquastat. And probably if you have any water heating system, probably you're gonna have an aquastat. Aquastat is it controls the temperature of the water.
So that where the temperature is on.
And aquastat is a brand name. It's a name given by Honeywell. It's a trademark. So see another company, they call it something else like hydrostat for water temperature control. But that term aquastat refers to Honeywell brand.
So how hot your shower is coming out because of that.
Now this is to control the water inside the boiler
Oh.
when you turn it on and off. So if you look here, we'll see the terminals. These are our connection terminals. And what do you think TT is?
What was the question?
What do you think the TT terminal goes to?
Different thermostats?
Thermostat. Remember that. We're gonna go over this a lot. And TT usually refers to thermostat.
Is that why it says thermostat right under it? Yeah.
See, they're making things easier. It says thermostat. They don't even rely on memory. But this company is very generous in putting in things on the board. Probably sometimes it's not going to say thermostat, and probably because they also have space. Some boards are very crowded, they cannot print stuff on it. What do you think L1 is?
Line one.
Line, so hot, you said hot. Excellent, it's hot. Line 2?
Neutral.
Neutral, fantastic. And if you look at the back, what are these? That means it's connection, right? Solid, so this line is connected all the way to this terminal here. And you can see how it's shaded, this is all connection. And burner, C1 and C1,
Common?
no?
What's that?
Circuits.
Like another common?
Good guess, but what are they? It's a
Circuits.
they didn't have enough space to put it, circulator, which is a pump. And ZC and ZR we'll talk about later. It's for zoning. So ZC and ZR, it's zoning. And going back again, to complete a circuit, you need the hotline, you need a load, I need neutral. Thank you very much. You're way ahead of the curve. Good for you. So if we look here, if we are going to supply the aquastat with L1 and L2, and this aquastat is going to control your burner and your circulator, what do you think is the B1? So if we want to be consistent, if L1 is hot, and this is controlling the power going to a circulator and a burner, what do you think B1 is? Hot for the burner. What about C1? Hot for the circulator. Which means C2 and B2 are what? Neutral. And if you look closely, you'll see the connection here. This is connection between B1, C1, all the way coming to L2. So what we're doing here is connecting all the neutral together. So we're following, I'm gonna have you one of the labs to draw a schematic for this aquastat, just to understand the why. So what happens if, for example, I ignore C1, C2 and B2, and I just connect all the neutrals to the L2. What will happen? Huh? You think so? Would it work? With this model, it will work. If it's, yeah, it will work because you completed the circuit and it didn't energize. With the electronic ones, probably it will not. To another neutral. The source neutral, it will be okay. But if you don't, in some electronic ones, if it does not get feedback, it will not work. So always try to stick to the terminals. I mean, there are some shortcuts. Instead of going back to the board, you can go outside and put neutral all the way to the L2 and get it down. It will work with these old ones. The new ones are more sensitive and they wait for the feedback, which is it's safer. So we get an idea, and this is simple aquastat, and there's not. What do you think this is? It has a coil. It has contacts. It pulls something in. What do we call it? Relay. Thank you very much. What about this thing? Huh? What is it? Transformer. Alright guys, you're awake. I'm really happy. Why do we need a transformer here in the aquastat?
To change the increase or decrease, something like that.
Excellent. Okay, you're good. And what is the line voltage here? And what is the thermostat power?
5.4.
Yeah, that's what is the thermostat. You guys are doing great. I'm very, very impressed. Excellent. So if you understand those little simple concepts, it's gonna take you far in wiring these components. You understand one of the components, what do they look like, and why do we need them? And this, why would you think this relay here, what is it doing? If you notice, this component here has high and low temperature. So this will control when the relay engage and disengage. And this, if the temperature inside the water, this water is connected to a sensor. Sensor goes into the tank. If the water is not within the limit, it will activate the relay. Relay will pull in, and the boiler will turn on. So main circuit, sub-circuit, another sub-circuit. So I'm really glad that you guys at least got all this simple concept here. We'll move on into schematics. And if you try to break things, bigger things, smaller components, they're not as overwhelming. Okay, so I'll move on with the schematic here. So let's look at this schematic. First look, they'll be like, okay, what is this? First look, it's exactly what Cass is doing right now. Like, okay, what is this? But let's take it step by step and not be overwhelmed. We have the line voltage coming in here. L1 is what? Hot? L2 is neutral. Okay. And they also call this a ladder diagram. It looks like a ladder, and it's top to bottom. We go down a little bit. What do we have here? Contactors. Excellent. What is this? It says over here, so we don't have to even guess. CRC, it's over here. Compressor running capacitor. Another capacitor here for kinetic motors. So are these connected in series or parallel?
Parallel.
Parallel. So this is the first step, which is the compressor. We're done. Second, what do we have? Crankcase heater. Is this and the compressor in series or parallel? Parallel. Excellent. First stage, second stage, third stage. What do we have?
And the fan motor.
Series or parallel with everything else. Parallel. Loads are always in parallel, so those are three in parallel. Easy so far? Even though it looks kind of overwhelming from the first look, it is actually consistent. What does this look like? Transformer. Excellent. What do we need transformer? For control. Control needs step down to 24 volts. We go down. Here's my control. This is the loads. These are my controls getting circuit from the board. This is a similar thing. We have a transformer here to get our secondary circuit. Let's look at the secondary circuit by itself, little by little. Voltage coming in, 24, same thing. And we have here few switches. If you notice, they put all these into a dashed square line. What do they think this is? This is a group together, which resembles what? What has R, G, and Y, and fan, and O2, and system?
Connections.
Huh?
Connections.
Yeah, but what do you think the whole box is here together? Thermostat, excellent. Excellent. Thermostat. This is my thermostat. I can ignore the whole thing, I just cover it up and say it's a thermostat. Fourth time. The thermostat, what does it do? It turns on the indoor fan motor relay, and the indoor fan relay turn on this fan motor over here. So these two are connected. And if we look at the C here, which is contactor. So this contactor connect those two in here. So the low voltage relay will activate this little contactor here, and those two will close, and we'll have compressor coming in. LP and the high P, what are those? Huh? High pressure, low pressure. These are safety switches, and they are connected in series with the circuit. If any of those open, the whole thing is deactivated, compressor is out, fan motor is out. Okay, how do you feel now compared to 2 minutes ago?
I still don't get like the second part.
It's I can understand why. So this is the first circuit, it's complete.
Yeah, I get that.
Second circuit, step down voltage, and these are the controls. What you're not seeing here is that contactor, the actual contactor here, is connected, is controlled by the control circuit, but it sends signals to those sides. So this is the back. The back, if you fold these together, this is the back of these contactor. This is the control part of it, and this is what it's closing over here.
I thought it was like a main like switch. I didn't know that. It was,
Yeah, I understand. It looks from the first visual to it, you think, okay, what's going on here? How is this related to that thing? Because I don't see the contactor, right?
Yeah.
I don't see it. But if I have to draw a line, imaginary line, it's not imaginary, it's real. It's a wire. Gonna be a wire coming from here to here, and from here to here, and we'll block these here. And same thing for here. These are connected together, and this is. Yep.
So can you just repeat one more time the square part? I didn't get that.
The square here, it's if you notice, has three wires which either connects this thing on the system, and this one will switch between the fan on or automatic, and this one is the thermostat which will close the circuit if it's too hot. So the whole thing here is the thermostat, which is over there that controls what's going on. So that they put a dash line around it just to make you, they give you some internal wiring, but not a lot. But you can just close this and put thermostat. However, when builds go through the thermostat board, you will have to connect and understand what is R, G, and Y. If you read any manual, probably it will tell you what the R and G and Y connected to. This schematic is in the book. Again, the first thing you do when you look at schematic is what? Don't freak out. Yeah, don't freak out. Do not panic. So you know all the components, you know the line voltage. Go and write down on it what you think this is. And even though this is very simplified, I don't even need this wire inside and I don't need these lines. So this is maybe a little too much information that I need, but if I try to just look at the wiring, it should be consistent. Some common symbols. Relay closed. This could be also a relay. This can be the coil, either this one or this one. And switches on and off. And also, If you find a new symbol that doesn't make sense, some company decided we're gonna change the symbol, go look at the margin. Look at the margin because the margin should tell you what is that. You should not know all the symbols by heart. You know? And they changed from one industry to another. How about this one? Yikes, huh? It looks like something I don't want to look at. But look at the legend. It's very.
You can read instruction, you should be able to do it.
See, there is too much information here. So what I would do is I'll start from my line voltage. I'll work my way up. And this is a board. This is a control board completed. And what am I concerned with here is where would I put my line voltage. Line 1, white, black. We're not gonna deal with something like that, at least in this class or the next class. But you can see how it gets a little bit involved, and there's a lot of details.
What is that the schematic for?
No, no. What is it? I think it's zoning control.
Is that the worst it's gonna get?
We're not even gonna use that.
Alright, good.
That's just for information.
Are we gonna use that in the field, like say we do like residential and stuff, or will it not be like?
You shouldn't, unless you're doing troubleshooting for some new equipment, you shouldn't. But it's a little bit overwhelming, don't you?
Have you ever had to do that?
Yeah.
So you've been in the field?
Huh? I got like, we get schematic that actually as a blueprint. We get schematic as a blueprint, really huge. So what do? You take it one step at a time and find, in a map, what do you do the first thing? Let's say, did any of you use the regular map for Google? Huh? Have you ever used the regular map?
Yes.
What the first thing you do?
Find
Find where you are. When you go to the mall, can't find a store, it tells you where you are. So the first thing you find is find where you are. And how do I find where I am now? I have my plug. That's my line voltage. I'll find my line voltage and trace my way out. And my line voltage is here, coming all the way from the wall. This is my switching relay, ground, black and white. This is my line voltage, and I keep it going. By April, we will wire industrial controls. It's going to look something like that, but we'll make it much simpler. We're going to cover everything in the middle. We don't care about what's inside. It's all going to be like just white space and just what do we plug into it. So, don't need to worry about that. Heater from the shutter, contactor, de-energized. What does de-energized mean? No power. Disconnect switch. That's the disconnect switch. Energized, it has power. Factual diagram, it has all the information in it. It has all the details, internal components that we really don't much care about. Fuse, heater, installation diagram, that's what you need. Just tell me what goes where. And usually all things are color coded, they are labeled as you see, and they try to make it very, very easy to connect. And some of them come with foolproof connections that you cannot connect the wrong way. What's a load? Everything that consumes electricity or uses electricity to do work. Magnetic overload, magnetic starter, and motors. What else? Normally, what do they mean by normally?
Something wrong.
It's the state when the system is de-energized. Right, unactivated. Normally closed.
How come closed and open are the opposite?
Huh?
Like closed circuit is the opposite of an open circuit? Like,
Yes.
How come it's like that?
Because sometimes they set it up to be closed. When you de-energize it, it's open. So you can. It's how you pull the contactor in and out. So I want it to be open. Once I activate the switch, I want it to close. Pictorial diagram. Basic diagram. Pilot duty device. What does that mean? Don't worry about it, but it's about some stuff that's always on until called upon. Like the thermostat is always on until it's activated. That's pilot duty. For a gas furnace, for a gas boiler, you have a pilot sometimes where the gas is always on. Pole, what's a pole? Huh? A connection. Pressure switch opens or closes the switch based on the pressure, whether it's high or low. Push button switches, elevator stuff, relay, schematic diagram, signal lights that tell you the circuit is on and off. A lot of controls now have signal lights, solenoids, coil that becomes a magnet and pulls in a contact or a pin. Solenoid can control a relay, solenoid can control a valve, solenoid can control a door, can open and close, it can open and close a valve as well. What else? Dampers can be controlled by solenoid as well. Okay, I want to go through the questions in the back of the book.
We're gonna have a release like
Friday. Yeah.
Remember the solenoid for like pipes, like water pipes?
Yeah.
If it's electrical, is it just for like cut?
Yeah.
Right?
Yeah.
Same thing.
Yeah.
What page is that?
Huh?
What page is that?
106. We'll start with John.
What chapter is this?
5.
Pictorial, schematic, and, yeah.
Pictorial, factual, and installation. You got that, everybody?
No.
Pictorial, factual, and installation. Question 2. A load is an electrical device that A, produces electricity, direct flow of electricity, assists in starting the motor, uses electricity to do useful work. Please. D. Good. What is the major load of air conditioning system? It's not the compressor composed of what? The compressor does not take, huh? What's connected to the compressor? What runs the compressor? Huh? No.
Contact.
What component?
Fan
Close.
The transformer.
Damn fans.
What's in a compressor?
Air.
Compressor is just a mechanical device, like a pump. Motor. Thank you. Extra point for this quiz. Identify the following symbols for load. What do you think that is?
Stop.
Contact
Audrey.
fan motor.
Your turn.
Actor fan motor.
Okay,
Condenser fan motor.
Cubic feet.
let us try. What about B?
I said that.
Damn. I had the last one I put right.
Coils.
What is it?
What's your form? Part B. What do that look like?
Oh, I'm sorry, I didn't do that one.
Okay. For Barney, what is B?
That was a compressor motor, right? No.
It's just a motor. Whose cause represent the motor? C, just a red light.
Red signal light?
Yeah.
Resistance?
Resistance. E.
C.
If you have to guess.
Gear.
Heater. Heater and the resistance are the same. Okay. Felipe, what is the major difference between a contactor and a relay?
Contact here is 120 amps.
Excellent. Thank you. What do the term normally open and normally close refer to with regard to a switch or set of contacts? Draw a normally open and normally closed contact. That's Neil.
What
Can you draw a normally closed and normally open contactor?
Yeah. It's just basically open, like an open hole, right?
Yeah. What does it look like? Thank you. There you go.
That's an
Yeah. Yeah, that's a switch. But if you see them like this, it's normally open.
Oh, yeah, yeah, yeah.
This is normally closed. Okay, thank you. This is gonna be in the quiz at some point, so you better pay attention.
Wait, so which one's the one that's open? The one that's open on top, right?
Yeah, normally open, normally closed.
That's open.
Identify the following symbols for relays and contactors. What does that look like?
Looks like a relay.
Manual.
Yeah, contact.
Is it normally open, normally closed? Normally open, single pole or double pole? Single pole. What about B? Double pole, normally
Yeah.
open. This one, what does it look like? Double pole, double throw. This one is open, one is closed. Double pole, which means the lines, and double throw. What about this one?
Row normally closed.
Double pole, single throw.
So what's the throw? Is it
A throw is the action. They're gonna do the same thing when this is energized, right?
Oh, right.
This one will do the opposite. One of them will close, one of them will open. So that's the throw. The pole is the number of lines. What about this one here? Triple throw, a triple pole, single throw. Write these down. It's gonna be in the quiz.
When, Friday?
No, quiz 4. So write these down.
What was C?
C, double pole, double throw. Because one of they are different.
Is D and B the same? Double.
D and B.
Double pole.
So if
Yeah.
if you had.
But this is, hold on, this is normally open though, and it's normally closed, that's no difference. But the name of the relay is the same. But, guys,
So if you have three
Guys.
and two are open and one is closed, it's double throw.
it's gonna be three poles, double throw.
So D is double
Do you
pole.
have a diagram on Blackboard with all these?
What do you say D was?
There's one here.
Pole, double close, right? D?
D.
There's a big diagram here with all the, here you go. If you wanna look at page 114, there's a big list of those, and I have some in the Blackboard as well. Huh? Draw a heating and cooling thermostat and explain the difference between them. That is a tricky one. Okay. So, this can be a little bit confusing for some, especially me. So, if this is a thermostat, and this is a spring, with this close when it's cold or when it's hot? When it's cold. So, is it a heating thermostat or a cooling thermostat?
Heating.
Heating thermostat. That's very smart. What about a cooling thermostat in that? So it's gonna look like that. When it's hot, this will expand and this will close. This is a cooling thermostat. So the way I remember it in my little brain is the expansion and contraction of the spring. I look at the spring, I think of the heat, expand things, and coolness, shrink things. This is the cooling and heating thermostat. Quiz material.
Okay.
A 3-pole contactor would allow how many paths for the current flow? Hold on, Mark. How many poles in the 3-pole? How many paths for 3-pole contactor? 3. So poles are the path. So a disconnect switch is used to open and close the main power source for a piece of equipment, stop and start the compressor, control the operation of electric heater, open when unsafe condition happen. What do you think? Who says A? You're right, it is A. This is a disconnect switch, and this what it does. Big switch. What determines whether a pressure switch opens or closes on the rise of pressure?
That's worded weird.
I know. We'll skip it, I don't like it. Identify the following symbols.
Wait, what was it?
Huh?
Wait,
Question 12, don't worry about it. Identify the following symbols for switches. What does this look like?
No switch.
It's a switch, yeah. What about this?
No switch. Just one.
It's a relay. It's a coil and a contact. That's the relay. Normally closed relay. Again, normally closed relay, same thing. Switch or coil, this is disconnect switch. You can refer the diagram on page 114.
Yes.
Actually, this is the fuse. Different symbols. Fuse in here. And if you look here, these are the contacts. Magnetic overload. So, again, with symbols, I usually go with the legend because from each book is different. And each schematic has different ones. So do not rely on this book for all schematics. What is the difference between a thermal overload and a magnetic overload? Draw a symbol for each one. What do you think? What's a thermal overload and a magnetic overload?
One of them burned, one of them just back.
Close. So remember we said that thermal overload has a small metal that when it heats up, it pops. So a thermal overload has a metallic part inside that expands and part will circle out. A magnetic overload has a coil that will become a magnet and pull in a contact. Make sense? So one of them is mechanical and one of them is electrical.
That's happening if there's an overload.
Yeah, they both do overload. One of them is by temperature, with a spring, pops out. That's a thermal one. The magnetic, as the name implies, it's a magnet and pulls in and out a switch. What do they look like? Let's see what the book wants. This is a magnetic overload. And where's the thermal one? This is a thermal overload. And if you notice here, this little archy thing looks like a smiley face. It looks like an angry eyebrow. It's not a smiley face. That's when it's hot, it will pop open and disconnect the switch. The magnetic has a coil, and the coil will open the relay when it's energized. Questions?
Yeah, number 13, what was E?
What was what? E?
Question 3. Yeah, what was
Circuit breaker.
E was a circuit breaker?
They have to compare with this, the circuit breaker. If I'm wrong, let me know. If I have to guess, it's a circuit breaker. Okay. What is the purpose of a transformer? Somebody said that already.
What?
What is the purpose of a transformer?
Certain areas of the unit.
Increase voltage.
Also to protect everything.
I'm saying.
Optimus Prime. No, it's to step down the voltage or step it up. So transfer voltage from high to low, low to high.
What?
Say that again?
He said.
It changes voltage from either high to low or low to high. Transforms in it. Which of the following is not a requirement for electric circuit?
D.
Huh?
D.
Who agrees with D? Okay. You guys win. Questions? Okay. What is the purpose of a legend in a schematic diagram?
So you can only.
So you can know what everything means. Especially if you have acronyms that know, some of them have 2 pages of legends. Factual diagram is a pictorial diagram with wire colors denoted, a combination of pictorial and installation wiring diagram, a combination of schematics, pictorial and wiring diagram, none of the above.
Schematic.
It's a combination, has everything in it. That's a factual. Too much information. All the facts are there.
So it's C, right?
C. Identify the following symbols for safety devices. What is this? Is it a cooling or heating thermostat?
Cool and heating.
That's a heating thermostat. Cooling thermostat.
Can't see that
You
one.
gotta
Yes,
find
here,
out.
figure.
That's it.
Heating.
What is this?
Pressure.
It's a pressure switch. So this is low pressure switch. Because if the pressure is low, it's gonna pull down, it's gonna open the circuit. And this is just a switch. Double throw switch. Double pole switch. Switches. Which of the following are not components of a contactor or relay? This is a good one. Solenoid, contacts, thermal element, mechanical linkage.
D.
Do you need a solenoid?
Yes.
Yes. Do you need contacts? Yes. You need thermal element? No, I don't need a thermal element. So
The
it's
girl
C.
said A.
Mechanical linkage, this I drew it over here. Mechanical is the arm that works back and forth. So those are three components. True or false?
C.
C. True or false? The schematic diagram tells the service technician how to wire a system. Yes. What is the difference between a pilot duty and a line brake overload?
Put it right in my lips right now.
Huh?
Hmm?
See that?
That's it.
What is the difference between a pilot duty and a line brake overload?
Pilot
will
duty.
stay on.
Pilot duty will stay on.
The other one will break.
The
Will just fall off.
line brake overload will shut off after the equipment is on. So one of them will be on all the time, one of them will cut off after the system is energized. What type of switch would you use to open and close a set of contacts at a certain pressure? It's very simple, pressure switch. You got it? What is the purpose of a fuse in an electrical system?
Safety.
Cut off the electricity.
Excellent. True or false? A solenoid valve is a device that opens or closes to control the flow of some elements in the system.
True.
True? What is the signal light used for a control system?
Tells
Yeah.
you what's activated.
Yes. Is it on or is it off? Change the following normally open element to a normally closed. What are you gonna do? Put a line across it. Draw symbols. Line, these both you can answer from this diagram here. 114. Okay. Please, if you have time, go through the book, skim through it. It's really a lot of good information. And review the video. We did mention a lot of information here, so look at the video. Does anybody even watch videos?
I tried, but I don't get it working.
YouTube?
Yeah, but I don't know if it was your video. I think you might have just like posted a link to
But
it.
we have a watch list. There's a watch list on Blackboard. It has all the videos in it.